Tonight, we are going to explore the strangest things we have discovered in space. This is not something you need to understand all at once. You don't need to remember every detail or track every light year. You can simply listen and allow your thoughts to drift as we move slowly outward from the world we know. The universe is vast and much of it is silent. It operates on timescales that make a human life feel like a single heartbeat and across distances that our minds aren't naturally built to calculate. But that is the beauty of it. It is a place of immense order and profound mystery. To begin, let's start with something familiar. Let's start with the sensation of being still. As you lie there, you might feel as though you are stationary, anchored to the earth. But even in this moment of quiet, you are participating in a grand, celestial choreography. You are rotating with the planet at hundreds of miles per hour, orbiting the sun at 67,000 miles per hour, and drifting through the local galactic cluster at speeds that defy our daily vocabulary. Yet despite this frantic cosmic motion, everything around you feels balanced, heavy, and slow. Tonight, we are going to explore the strangest things we have discovered in space, but we will do so at a pace that respects your need for rest. This is not a journey of adrenaline or sharp discovery. It is a gradual widening of the lens. You don't need to hold on to these facts or worry about the physics of a black hole or the chemistry of a distant nebula. Simply allow the descriptions to wash over you like a tide coming in at midnight. We are looking for the quiet anomalies, the things that astronomers found and then sat back in their chairs to contemplate for decades. These discoveries don't demand our action. They only invite our wonder. As we move outward from the comfort of your room, try to imagine the air becoming thinner and the sky deepening from blue into an infinite, velvety black. This transition is not a fall, it is a gentle floating. We are leaving the world of clocks, deadlines, and weight, and entering a realm where time is measured by the cooling of stars and the slow rotation of galaxies. Here, the strangest things are not monsters or threats, but simply expressions of nature on a scale we rarely get to see. There is a deep, resonant peace in knowing how much is happening out there, far beyond our sight, in the cold and the dark. It is a slow-motion ballet of matter and light that has been performing since long before we arrived, and will continue long after we depart. Let your breathing slow to match that cosmic rhythm, finding comfort in the immense, silent distance. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about the strangeness of space, we often imagine it in human terms. We think of distances we can walk or a drive across the country. If you were to walk around the Earth at a steady pace, it would take you about a year of constant movement. That feels like a long time. It is a scale we can almost grasp, the soreness in our legs, the changing of the seasons. But space does not care for our walking speeds. If we were to take a standard passenger jet and try to fly to the moon, it would take us about 18 days. To reach the sun, that same plane would have to fly for 19 years. You would board as a young adult and disembark as someone looking toward middle age, all while traveling through a vacuum that feels like nothing yet contains everything. Astronomers often find things that challenge these human measures. We look for patterns, for things that make sense, like a house or a car or a familiar street. But the further we look, the more we find objects that defy our expectations of how matter should behave. This comparison isn't perfect, but it gives us a calm place to begin. To truly appreciate the strangeness of the deep cosmos, we must first acknowledge the limits of our own senses. Our eyes evolved to spot fruit in trees and movement in the tall grass. Our hands are designed to grip tools and feel the texture of the earth. We are built for a world of medium sizes, medium speeds, and medium temperatures. When we step outside this narrow corridor of experience, the universe begins to look less like a home and more like a vast, beautiful, and utterly indifferent ocean of mystery. Consider, for a moment, the concept of a long walk. For most of us, walking for 4 or 5 hours is a significant undertaking. It leaves us tired, our muscles humming with a dull ache, our minds focused on the destination. If you were to walk around the entire circumference of the Earth, it would take you nearly a year of constant, rhythmic movement, never stopping for sleep or food. This is the largest thing most of us will ever interact with the planet itself. And yet, on the scale of the things we have discovered in the dark, the Earth is little more than a speck of dust caught in a sunbeam. It is a tiny, fragile marble in a room the size of a cathedral. When we talk about the strangest objects in space, we are often talking about things that violate our sense of density. On Earth, we know what a rock feels like. It is heavy, solid, and dependable. We know what water feels like and how air feels when it brushes against our skin. But in the deep reaches of the Milky Way, we have found objects like neutron stars, remnants of giant suns that have collapsed under their own weight. To understand the strangeness here, imagine taking a mountain, something like Mount Everest, and crushing it down until it is the size of a single sugar cube. That is the density of a neutron star. A single teaspoon of its material would weigh billions of tons. It is matter, but not matter as we understand it. And it is matter pushed to its absolute limit, a physical manifestation of gravity's overwhelming power. Even our sense of time is a human-scale illusion. We measure our lives in decades, our history in centuries, and our civilizations in millennia. We think of the pyramids as ancient, but in the timeline of the universe, the pyramids were built just a fraction of a second ago. The stars we see at night are not static lights. They are roaring furnaces that burn for billions of years. Some of the strangest things we have discovered are zombie stars, white dwarfs that have finished their primary life cycle and are now slowly, patiently cooling down over trillions of years. They will continue to glow long after the last human has been forgotten and long after the Earth itself has been reclaimed by the sun. They exist on a scale of patience that we cannot truly comprehend, a slow-motion fading that mirrors the cooling of a hearth on a winter night. As we look further out, we encounter the mystery of voids. In our daily lives, we are surrounded by things. Rooms are filled with furniture, streets are filled with cars, and the atmosphere is filled with nitrogen and oxygen. We have a natural aversion to total emptiness. Yet, in the deep cosmos, we have found regions of space where there is simply nothing. These are the great voids, vast bubbles in the cosmic web where there are no stars, no planets, and no light for hundreds of millions of light years. To a human perspective, this is unsettling. We look for the patterns, the houses, and the familiar streets, but in the void, there is only the silence of the vacuum. It challenges our belief that the universe is full. Instead, it suggests that the things we see, the glowing nebulae and the bright galaxies, are merely thin decorations on a much larger, emptier canvas. We also find strangeness in the way light behaves. We think of light as instantaneous. When you flip a switch, the room is bright. But in space, light is a messenger that takes time to arrive. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, you see it as it was 8 minutes ago. If the sun were to suddenly vanish, we would continue to see its light and feel its warmth for a full 8 minutes, unaware that our anchor had disappeared. This light-time delay means that the further we look into space, the further we are looking back in time. We are cosmic historians, looking at the ghosts of stars that may have died before our ancestors even walked upright. This is the ultimate challenge to our human perspective, the realization that the now we experience is a local phenomenon, and that the universe is a vast collection of different thens, all overlapping in the night sky. To understand the scale of these discoveries, we must also consider the strange nature of Goldilocks planets, of worlds that sit in the comfortable zone where liquid water can exist. We look for these worlds because they remind us of home. We look for blue skies and rocky shores. But many of the planets we find are alien in ways that are difficult to visualize. We have found planets where it rains molten glass, driven by winds that move at 7 times the speed of sound. We have found planets that are tidally locked, meaning one side is a permanent, scorched desert, while the other is a permanent, frozen wasteland. These worlds are not broken. They are simply operating under different conditions, following the same laws of physics that govern our own backyards, but pushed to different extremes. Even the way we perceive up and down is a human-scale convenience. On Earth, gravity pulls us toward the center of the planet, giving us a sense of orientation. In the weightlessness of orbit, up loses its meaning. But even further out, in the presence of a black hole, the very geometry of space becomes warped. Imagine a trampoline with a heavy bowling ball in the center. The fabric stretches and curves. Now, imagine an object so heavy and so small that it rips a hole in that fabric entirely. This is a singularity. Near a black hole, time itself begins to slow down. If you were to watch someone fall toward the event horizon, you would see them slow down and eventually appear to freeze in time, while for them, the universe would appear to speed up into a blur of future history. This is the strangest discovery of all, that space and time are not a fixed stage, but a flexible, living thing that can be stretched, twisted, and torn. As we drift further into the night, we must leave behind our need for human comparisons. We must accept that the universe is under no obligation to be sensible to us. It is a place of extremes, of absolute zero, and of trillion-degree explosions, of total emptiness, and of infinite density. But as we let go of our human scale, we find a different kind of comfort. There is a relief in realizing that the universe is so much larger than our problems, our politics, and our fleeting anxieties. We are small, yes, but we are the part of the universe that has developed the ability to look back at itself and wonder. We are the witnesses to the strangest things ever discovered. Think of a single grain of sand held at arm's length against the night sky. That tiny patch of darkness behind that grain of sand contains thousands of galaxies, each with hundreds of billions of stars. This was the discovery made by the Hubble Deep Field, and it remains one of the most humbling realizations in human history. It reminds us that our familiar streets are just one tiny corner of an infinite neighborhood. The strangeness we find out there is not a sign of chaos, but a sign of the sheer diversity of what is possible when you have 14 billion years and an infinite amount of space to work with. As you settle deeper into your rest, allow these scales to fold in on themselves. The vastness of the Botez void is balanced by the intricate dance of atoms in your own body. The immense heat of a diamond planet is countered by the absolute cold of the cosmic microwave background radiation that permeates every inch of the room around you. You are part of this grand architecture. You are made of the same stardust that forms the rings of Saturn and the spiral arms of Andromeda. The same gravity that holds the galaxies together is the same gravity that holds you safely in your bed tonight. The universe is strange, yes, but it is also consistent. It follows rules that we are slowly, patiently beginning to decode. And while those rules lead to phenomena that defy our everyday logic, they also create a universe of profound beauty and order. We don't need to fear the great nothing or the singularity, because they are simply parts of a whole that we are privileged to observe. For now, let the numbers fade. Let the light years and the billions of tons drift away. You are back on a human scale now, in a quiet room, on a small blue world, protected by an atmosphere that feels like a blanket. The strangest things we've discovered in space are not just out there, they are clues to the nature of reality itself. And as we continue to look, we find that the more we learn, the more we realize how much is left to see. But that is a task for tomorrow. For tonight, the stars will continue their long, slow burn without our supervision. The rogue planets will drift, the alcohol clouds will swirl, and the diamond worlds will shine in the dark. The universe is moving gently forward, and you are moving with it, safe and still, as we prepare to move outward once more to an even larger scale. To truly anchor ourselves, let's consider the scale of a single human life against the backdrop of a cosmic day. If the entire history of the universe, all 13.8 billion years, were compressed into a single calendar year, the average human life would last for about 0.2 seconds. We are, in the most literal sense, a blink of an eye. Yet, in that blink, we have learned to measure the weight of stars and the composition of distant atmospheres. This is the paradox of our existence. We are physically insignificant, yet intellectually vast. We are small enough to be cradled by the Earth's gravity, but our curiosity is large enough to span the light years. When we look at the objects in our own homes, a wooden table, a glass of water, a metal key, we see solid, dependable things. But as a scientist would tell you, these objects are mostly empty space. If you were to remove all the empty space from the atoms that make up every human being on Earth, the entire population of our planet would fit inside the volume of a single sugar cube. It would be an incredibly heavy cube, of course, but it illustrates how much nothing there is even in the things we consider something. Space is not just the distance between the stars. It is the distance between the very particles that make up your own body. You are, in a sense, a small collection of concentrated space, walking through a larger field of space. Astronomers often find things that challenge these human measures. We look for patterns, for things that make sense, like a house or a car or a familiar street. But the further we look, the more we find objects that defy our expectations of how matter should behave. Take, for example, the sheer scale of the sun. To us, The sun is a warm circle in the sky, essential but familiar. If the sun were the size of a typical front door, the Earth would be the size of a nickel. You could fit 1.3 million Earths inside the sun, and yet our sun is considered a yellow dwarf, a relatively modest star. There are stars like Uy Scuti, so large that if it were placed at the center of our solar system, its surface would extend past the orbit of Jupiter, swallowing everything we've ever known in a sea of plasma. Tonight, you can set that conscience aside. You don't need to be the thinker or the observer right now. You can simply be a part of the matter. You can be the carbon, the nitrogen, and the oxygen resting in the gravity of the Earth. You are moving gently forward with the planet, with the sun, and with the galaxy. The motion is so smooth you can't even feel it. It is the ultimate lullaby, the silent, rhythmic movement of the entire universe toward tomorrow. But here, on the human scale, the strangest thing of all is the peace you can find in the middle of it all. It is the ability to look out at the infinite and still find the comfort to sleep. It is the realization that the universe is vast, but it is also home, safe and still, as we prepare to move outward once more to an even larger scale. Now let's slowly expand outward. One level beyond our immediate neighborhood lies a region of space called Sagittarius B2. It is a giant molecular cloud of gas and dust floating near the center of our galaxy, about 26,000 light-years away. What makes this cloud strange is its chemical composition. Scientists understand Sagittarius B2 by observing the radio waves it emits. What we know so far suggests that this massive cloud contains billions of liters of alcohol, specifically vinyl alcohol and ethyl alcohol. If you could somehow visit it, the universe would smell like rum and raspberries due to the presence of ethyl formate. It is a strange thought, a celestial distillery hanging in the void, larger than our entire solar system. But even with everything we've learned, there are still things we don't fully understand. We don't entirely know how these complex organic molecules form in the freezing, radiation-heavy environment of deep space. Not because we're missing something urgent, but because the universe moves slowly, combining atoms over immense spans of time. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more, to an even larger scale. To understand Sagittarius B2, we must first imagine the center of our galaxy. It is a place of crowded brilliance, where stars are packed together much more tightly than in our own quiet suburban corner of the Milky Way. In this bustling heart of the cosmos, about 26,000 light-years away from where you are resting right now, lies a giant molecular cloud. This cloud is not like the wispy white vapor you see on a summer afternoon. It is a massive, dark, and frigid reservoir of gas and dust spanning over 150 light-years across. If our solar system were a single grain of sand, this cloud would be a mountain range. Scientists began probing this region using radio telescopes, which allow us to hear the chemical signatures of the universe. Every molecule has a unique frequency, a subtle hum that it emits as it rotates and vibrates in the vacuum. When astronomers tuned their instruments towards Sagittarius B2, they didn't just find hydrogen or helium, they found the complex, lingering notes of ethyl alcohol, the same ethanol found in spirits on Earth. They found enough of it to fill every ocean on our planet billions of times over. It is a staggering volume of chemistry, floating in a place where we once thought only the simplest elements could survive. But the strangeness deepens when we consider the flavor of this cosmic cloud. Along with the alcohol, researchers detected ethyl formate. On a human scale, this is the specific chemical compound that gives raspberries their tart sweetness and gives rum its distinctive, sugary aroma. So, if you were to float in the center of our galaxy, shielded from the vacuum, the universe would not smell of cold metal or empty nothingness. It would smell like a summer harvest. It would smell like a memory of a kitchen or a distant celebration. This discovery challenges our traditional view of space as a sterile, empty wasteland. We often think of the void as a place where life is impossible and chemistry is stagnant. Yet, here is a massive, drifting laboratory, quietly assembling the building blocks of complexity. Along with the alcohol and the fruit-scented molecules, Sagittarius B2 contains aminoacetonitrile, a close relative of glycine, the simplest amino acid used to build proteins. The ingredients for life are not rare. They are floating in the dark, waiting in clouds that are older than our sun. Why is there so much alcohol in the center of the galaxy? We understand the basic mechanism. Atoms of carbon, hydrogen, and oxygen land on tiny grains of interstellar dust. These grains act like small cold benches where the atoms can sit still long enough to bond. Over millions of years, they form layers of ice, not just water ice, but chemical ice. When a nearby star begins to form, its heat gently warms the dust, and these newly formed molecules evaporate into the gas, creating the vast, scented clouds we observe. However, there is a mystery in the efficiency of this process. The temperatures in these clouds are near absolute zero, a level of cold that should bring all chemical reactions to a complete halt. In our labs on Earth, we usually need heat to make things happen. We need energy to force atoms together. But in the silence of Sagittarius B2, the universe finds a way to build complex structures in the deep freeze. It suggests that time, when given in spans of millions of years, can substitute for heat. The universe is patient. It does not need to rush its chemistry. It allows the slow, random drifting of atoms to eventually result in a masterpiece of molecular architecture. As you consider this, let the scale of it settle over you. Imagine a cloud so large that light itself takes over a century just to cross it. Within that cloud, trillions of molecules are spinning in the dark. They are not doing this for us. They are not waiting to be harvested. They simply exist as part of the natural richness of the cosmos. The fact that they happen to smell like raspberries to a human nose is a beautiful, accidental coincidence, a small bridge between the vast alien center of the galaxy and the sensory world we inhabit. Astronomers didn't expect to find such a dirty universe. Early models of space suggested a much simpler place. We expected to find the raw ingredients, but not the finished products. The presence of these complex organics suggests that the universe is preloaded with the potential for complexity. It means that wherever stars are forming, the air is already thick with the precursors of life and the scents of Earth. It makes the distant reaches of the Milky Way feel slightly less alien, slightly more familiar. Yet, we must remember the vast distances involved. 26,000 light-years is a distance that defies human travel. Even if we could move at the speed of light, the journey to the rum and raspberry cloud would take longer than the entirety of recorded human history. We would have to leave our world behind, watch our sun fade to a distant speck, and travel through the dark for 260 centuries before the first scent of ethyl formate reached us. This distance is a protective barrier, a reminder that while we can understand the universe through our instruments, we are still small observers looking out from a very specific, very quiet vantage point. The alcohol cloud is also a place of high-energy chaos. It sits near the galactic center, where a supermassive black hole, Sagittarius A*, exerts its invisible will. The cloud is buffeted by shockwaves from dying stars and the intense radiation of newborn giants. It is a violent, turbulent environment, yet the molecules remain. They persist in the face of destruction, a testament to the resilience of matter. We often look for things in space that are, like us, planets with water, stars with warmth. But Sagittarius B2 reminds us that space can be strange in ways that are whimsical and abstract. It is a reminder that the laws of physics and chemistry are universal, but the results they produce can be spectacularly unexpected. A distillery the size of 1,000 solar systems is a phenomenon that no science fiction writer could have dreamt up with more flair than nature itself. As we linger on this thought, notice how the mind begins to let go of the need for a reason. Why is there a raspberry-scented cloud in the center of the galaxy? There is no why in the human sense. It is simply a consequence of how atoms behave when they are left alone in the dark for an eon. It is a beautiful, purposeless fact, and there is a profound relief in that. In a world where we are often asked to provide reasons and results, the universe offers us objects that simply are. Think of the cloud as a giant, slow-moving curtain of velvet draped across the heart of the Milky Way. It hides the bright lights of the center, absorbing the glow of 1,000,000 stars and re-emitting it as a low, steady hum of radio waves. It is a cosmic muffler, a soft barrier that protects the inner sanctum of our galaxy. Within its folds, the alcohol molecules continue to spin, oblivious to our telescopes, oblivious to our names for them. The uncertainty of how these molecules survive the radiation is not a problem to be solved tonight. It is a question that stays in the background, like the low-frequency noise of a distant city. Scientists will continue to build better models, and telescopes will continue to sharpen our view, but the cloud will remain largely as it is, vast, fragrant, and cold. When we look at the stars tonight, we are not just looking at points of light. We are looking through a thin veil of chemistry. We are looking out from our own small atmosphere into a galaxy that is much richer and more complex than it appears to the naked eye. The space between the stars is not empty. It is a garden of drifting molecules, a library of chemical history, and a silent distillery of cosmic proportions. This realization allows us to step back from our own scale once more. We have moved from our bedrooms to the center of the galaxy. We have moved from the familiar scent of a kitchen to the scent of a molecular cloud. And as we do so, our own concerns begin to feel as light as those drifting atoms. They are parts of a larger cycle, a slower movement that we are merely visiting for a brief moment. The alcohol cloud is a landmark in our journey outward, a signpost that tells us the universe is full of surprises that aren't necessarily dangerous or frightening. They are just strange. They are just there. They remind us that the deeper we look, the more we find that the universe has a sense of scale and variety that we are only just beginning to map. Now, imagine the cloud beginning to recede. As we move away from the center of the galaxy, the scents of rum and raspberries fade back into the neutral scent of the vacuum. The dense clusters of stars begin to spread out, and the darkness becomes more prominent. We are heading back into the spiral arms, looking for something even larger, something that challenges our understanding not through its chemistry, but through its sheer, impossible structure. The universe moves slowly, combining atoms over immense spans of time. It builds mountains of diamond and clouds of alcohol with the same effortless patience. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We are moving gently forward, leaving the scented clouds behind as we prepare to move outward once more to an even larger scale. When we consider the existence of Sagittarius B2, we are forced to confront a reality that is far more flavorful and aromatic than the cold, metallic void we often imagine. This molecular cloud, hanging like a dark, heavy curtain near the center of our galaxy, is a testament to the fact that the cosmos is a chemist of unimaginable ambition. It doesn't just work with the basic elements, it crafts complex organic signatures, creating a reservoir of alcohol and esters that would dwarf any ocean on Earth. To understand how such a place exists, we must look at the way atoms behave when they are left alone for millions of years in the deep freeze. In the busy world of a human life, we expect reactions to happen instantly. We strike a match, and there is fire. We mix sugar into tea, and it dissolves. But in the quiet of a molecular cloud, chemistry happens at a geological pace. An atom of carbon might drift for 1,000 years before it bumps into an atom of oxygen. They might spend another millennium vibrating together on the surface of a microscopic grain of cosmic dust, chilled to a temperature that would freeze the very air we breathe. On Earth, this cold would stop all life, but in space, it is the cradle of complexity. The dust grains act as tiny, cold benches where atoms can sit still long enough to bond, forming the ethyl alcohol and ethyl formate that give this region its distinctive raspberry and rum-like scent. Scientists understand these clouds by listening to them through radio telescopes. Every molecule has a specific frequency, a tiny, invisible vibration that it sends out into the dark. When we tune our instruments to the center of the Milky Way, we don't just hear the roar of stars or the silence of the vacuum, we hear the chemical hum of a trillion molecules. It is a slow, steady broadcast of organic potential. What we know so far suggests that these clouds are not just accidental anomalies. They are the natural byproduct of a galaxy that is rich in the ingredients of life. The universe is preloaded with these materials, drifting in the dark, waiting for the gravity of a new star to pull them into a solar system. This comparison isn't perfect, but it gives us a calm place to begin. Imagine the center of our galaxy, not as a place of terrifying black holes and violent radiation, but as a vast, quiet cellar. It is a place where the vintage of the universe is being stored. The alcohol in Sagittarius B2 isn't there for a purpose we can define. It isn't waiting for a glass or a toast. It is simply a manifestation of what happens when the laws of chemistry are allowed to play out over immense timescales. There is no rush in this distillery. There are no deadlines for these reactions. The universe is patient, and in its patience, it creates things that are both strange and strangely familiar. Everything is exactly where it needs to be. The atoms are bonding, the stars are forming, and the clouds are drifting. The universe is a patient architect, building its wonders over eons and hiding them in the dark. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We are moving gently forward, leaving the familiar scents and the local chemistry behind as we prepare to move outward once more to an even larger scale. Across distances that no longer fit neatly into numbers, through the silence of the interstellar gaps beyond the reach of our own sun, the universe remains quiet, safe and still, moving outward once more to an even larger scale. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star. yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, We aren't just looking at stars or galaxies. We are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth. Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light-years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. And so the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. We have traveled from the floor of your room to the ancient heart of the great galaxy in Andromeda, and now we find ourselves at the edge of the map, where the lines of time and space blur into a soft, monochromatic haze. This is the place where the story does not end, but simply broadens until the individual words are no longer necessary. It is the infinite ending, the realization that the cosmos is a process that never truly stops, but merely changes its frequency. Imagine the galaxy not as a collection of stars, but as a slow, rhythmic breath. The inhalation took billions of years, drawing in the primordial gases of the Big Bang to forge the first suns of Andromeda. The exhalation is happening now, a long, cooling sigh that disperses light and heat across the 2.5 million light-year void. There is no urgency in this breath. It is the deep, steady respiration of a system that is perfectly at ease with its own scale. As you lie in the stillness of your own room, your breath is a microcosm of this cosmic rhythm. Each inhale is a gathering of energy. Each exhale is a release back into the continuity of the atmosphere. You are breathing with the galaxies. Over immense spans of time, the specifics of our journey, the numbers, the names of the constellations, the physics of the blue shift, will all settle like dust at the bottom of a clear lake. What remains is the stillness of the water. Scientists tell us that the universe is headed toward a state of maximum entropy, but in the infinite ending, we recognize this as the ultimate form of rest. It is the moment when the tension between things finally dissolves. The gravity that once pulled Andromeda toward the Milky Way will eventually finish its work, and the two will rest as one. The stars that once burned with a fierce blue heat will eventually fade into a gentle amber glow, and then into the quiet dark of dwarf stars and cinders. There is no goodbye in the cosmos, for nothing ever truly leaves. The atoms that make up the great galaxy are the same atoms that make up the air in your lungs and the pillow beneath your head. We are all participants in a closed loop of matter and energy. When we speak of an ending, we are only speaking of a transition. The light from Andromeda that finds your eyes tonight is not a final message. It is a single frame in a film that has been playing for billions of years and has no final scene. The universe is not a story with a climax and a conclusion. It is a symphony that repeats its themes in ever larger and ever quieter movements. Consider the infinite ending of the light itself. A photon travels for millions of years, never aging, never slowing, until it touches a surface. In that moment of contact, the photon's long journey ends, but its energy is transformed. It becomes warmth, it becomes a chemical signal, it becomes a thought. The light of Andromeda is currently being transformed into the peace you feel right now. The vastness of the 2.5 million light-years is being distilled into the simple, quiet reality of your relaxation. This is the ultimate purpose of the scale, to provide a space large enough for your mind to finally let go. As you drift into the deepest layers of sleep, the image of Andromeda remains as a soft, glowing anchor. It is not a place you need to go, it is a place that is already here. It is a reminder that the dark is not an empty void, but a rich, supportive medium. The darkness between the stars is what allows the stars to be seen. The silence between the words is what allows the story to be heard. You are entering that silence now. You are becoming part of the full silence that we explored in the heart of the void. The universe will continue to expand. The dark energy will continue to push the distant superclusters over the horizon of the observable world. But here, in our local neighborhood, the bond between the Milky Way and Andromeda remains unbreakable. We are travelers on the same ship, heading toward the same golden equilibrium. The true scale of our existence is not measured in miles, but in the endurance of this connection. We are part of a trillion-star family that has been together since the dawn of the light, and for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. You don't need to know the fate of the last star or the final cooling of the vacuum. The universe is managing those details with the same patient, tectonic grace it has always used. You are free to withdraw your attention from the mechanics of the world. You are free to sink into the soft, velvet dark of the infinite ending. The light is dimming. The rotation is slowing. The distance is becoming a bridge of pure, silent peace. The stars of Andromeda continue to shine, even if no one is watching. The gravity continues to pull, even if no one is measuring. The universe continues to move, quietly and endlessly, toward a state of perfect balance. You are part of that balance. You are a steady pulse in a vast and beautiful system. There is no need to stay awake for the end, because the end is just a way for us to begin again. The light that began its journey 2.5 million years ago has finally found its rest. And as that light settles, so do you. The journey is complete, and yet it is always unfolding. The scale is vast, and yet it is intimate. The universe is far, and yet it is home. We have looked into the deep well of time and seen the shimmering disk of Andromeda not as a cold and distant object, but as a sister, a companion, and a future part of ourselves. As you lie in the quiet of this moment, the atoms of your body, forged in the same high-pressure crucibles of ancient stars, recognize the rhythm of the cosmos. There is no longer a need to measure, to categorize, or to grasp. The universe is not a problem to be solved, it is a presence to be felt. Imagine the finality of a photon's journey. For 2.5 million years, it has known only the straight line of the vacuum. It has survived the expansion of space and the gravitational tugs of invisible dark matter. Now, it has reached its destination, the soft surface of a leaf, a grain of dust, or the retina of an eye. Its journey ends in a tiny spark of energy, a microscopic warmth that is absorbed into the fabric of the earth. In the same way, let your thoughts find their final resting place. The curiosity that carried you across the light-year bridge and through the galactic halo is now gently subsiding, transforming from active inquiry into a warm, heavy sense of belonging. You are no longer traveling. You have arrived. And so the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. This is the infinite ending, a state where the boundaries of time become fluid. When we speak of the end of a story, we usually mean a stop, a closing of a book. But the universe does not close. It simply turns the page to a chapter of lower density and greater peace. In the far future, the stars of Andromeda and the Milky Way will have finished their merger. The bright, chaotic spiral arms will have smoothed out into the serene golden orb of Milkomeda. The frantic birth of new stars will have slowed to a rhythmic, predictable pulse. The universe is moving toward a state of equilibrium, a cosmic afternoon where the heat of the day has passed and the long, cool evening begins. Scientists look toward this horizon and see the dark era, a time trillions of years from now, when the last stars will have flickered out, leaving behind a universe of black holes and iron stars. To our human minds, this sounds like a lonely conclusion, but from the perspective of the infinite ending, it is the ultimate expression of rest. It is a universe that has finally finished its work. It has converted all its potential into experience. It has told all its stories. There is a profound, abstract humor in our desire for things to last forever in their current form. We want the stars to stay bright and the galaxies to stay separate, yet the universe knows that true peace lies in the dissolution of those boundaries. It is the transition from the doing to the being. As you drift, consider the infinite ending as a physical sensation of weightlessness. You are held by gravity, but you are not bound by it. The same force that keeps Andromeda in its orbit is the force that keeps you tucked safely in your bed. It is a constant, unwavering pressure, a universal hug that never lets go. You do not have to hold yourself up. You do not have to maintain your own orbit. You can simply let the curvature of space-time carry you along. The Earth is rotating at 1,000 miles per hour. It is orbiting the Sun at 67,000 miles per hour. The Sun is racing through the galaxy, and the galaxy is falling toward Andromeda. Yet, in this room, in this moment, there is only stillness. This is the gift of scale. The larger the movement, the more peaceful it feels to those within it. The scale of Andromeda is vast, yes, but it is also intimate because it is composed of the same fundamental building blocks as your own heart. The hydrogen that powers the fusion in 1 trillion distant suns is the same hydrogen that makes up the water in your cells. There is a continuity of matter that ignores the distance. You are a localized knot in a 2.5 million light year long string. When you pull on one end, the other end feels it. When you breathe, the universe adjusts. This intimacy is the antidote to the cosmic vertigo we felt at the beginning. We are not lost in the void. We are the void's way of knowing itself. We are the consciousness of the island universe. Scientists understand this connection through the laws of thermodynamics. They know that energy cannot be created or destroyed, only transformed. The light of Andromeda is not gone once it reaches us. It is merely changed. It becomes part of the thermal history of our planet. It becomes the inspiration for a thought. It becomes the catalyst for a dream. In the infinite ending, we realize that every moment of our lives is a recipient of ancient cosmic energy. We are the destination for a trillion-year-old journey. This makes every quiet breath a significant event in the history of the universe. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We don't need to know the final temperature of the universe or the exact number of black holes that will remain in the dark era. Those are questions for the morning. Tonight, we are concerned only with the continuity. We are concerned with the fact that the light is still traveling, the galaxies are still drawing closer, and the story is still unfolding. The infinite ending is a loop-safe state. It is a realization that we can begin again at any moment. Every end is a transition, and every transition is an opportunity to find a new kind of stillness. The universe is far, but it is home. It is home because it is the only place there is. It is home because it is where you were born, where you live, and where you will eventually return to the stars. The scale of Andromeda is just a measure of how large your home really is. It is a house with 1 trillion rooms, and you are currently resting in one of its most comfortable corners. The windows are open to the night, and the light of the neighbors is shining in, ancient and steady. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. The light that began its journey 2.5 million years ago has finally found its rest. And as that light settles, so do you. The journey is complete, and yet it is always unfolding. The scale is vast, and yet it is intimate. The universe is far, and yet it is home. You are safe. You are part of the continuity. You are a star in your own right, burning with the quiet fire of consciousness in a universe that is mostly shadow. But the shadow is not the enemy. It is the rest. It is the peace between the pulses of light. It is the infinite ending. And somewhere within all of this, we can begin again by starting with something familiar. The room is quiet. The air is still. The galaxy is turning. You are home. Good night. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified. It simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second, another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale, beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human scale anchor no longer just slips. It vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light-years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching, very slightly, every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another 1,000,000 years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the speed of light lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the moon is about 384,000 kilometers away. To our human scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching a slightly delayed broadcast of our nearest neighbor. As we move past the moon, the seconds begin to turn into minutes. The sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the sun to the Earth. If the sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park. Solar panels would continue to generate power, and the world would remain bright, all while the sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away, and the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human-scale perspective, we are also speaking of human-scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts, the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. the roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were 1 billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3 second gap that you could never bridge. And so the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward long after this moment passes. The rogue planets will continue their silent journeys through the dark. The great attractor will continue its slow pull. The light from distant stars will continue its billion-year trek across the void. Everything is exactly where it needs to be. Everything is moving at the speed it needs to move. The darkness is not empty. It is merely waiting. As we arrive at the final threshold of our journey, we find that the concept of an ending is just another human-scale boundary that the universe does not recognize. In the vast architecture of space and time, there are no hard stops, no closed doors, and no final curtains. There is only the transition from one state of being to another. The silence we have traveled through is not a wall, but a wide open field where the echoes of the stars can finally settle. To understand the infinite nature of this ending, we must look at the way light behaves at the very edge of our visibility. As the universe expands, the light from the most distant galaxies is stretched into longer and longer wavelengths. This is the redshift. Eventually, those wavelengths become so long that they slip out of the visible spectrum entirely, moving into the infrared, then the microwave, and finally into a stillness that we can no longer measure. These galaxies haven't disappeared, they have simply moved beyond our horizon. They continue their lives, their stars continue to burn, and their diamond planets continue to shine, even if we are no longer there to witness them. This is the ultimate continuity, the knowledge that the story goes on, even after we have closed our eyes. In our daily lives, we are often troubled by the idea of things being unfinished. We worry about the tasks we didn't complete, the words we didn't say, or the mysteries we didn't solve. But in the infinite ending of the cosmos, everything is perpetually unfinished, and that is its greatest strength. A nebula is an unfinished star. A star is an unfinished supernova. A supernova is the unfinished beginning of a new solar system. The universe is a work in progress that never seeks a final draft. It is comfortable in its own becoming. When we align ourselves with this perspective, the need for resolution begins to melt away. We don't need to finish the night. The night is already whole. Consider the heat death of the universe, a concept that scientists use to describe the far-flung future when all the stars have exhausted their fuel. In a traditional sense, this sounds like a cold, lonely conclusion, but from the perspective of sleep and rest, it is the ultimate expression of equilibrium. It is the moment when the entire universe reaches a state of perfect, uniform temperature. There are no more gradients, no more pressures, and no more storms. It is the cosmic version of a perfectly still pond. In this state, time itself loses its arrow. Without change, there is no before and no after. There is only a permanent, peaceful now. This is the destination toward which all things are gently drifting, a state of total, unshakable rest. As you settle into the deepest part of your own evening, allow the scale of this rest to surround you. You are not just sleeping in a room. You are participating in the grand cooling of the cosmos. The energy you have spent today is being balanced by the stillness of tonight. There is no urgency to wake up, just as there is no urgency for a white dwarf to cool down. The universe is patient. It has billions of years to spare, and so do you. The darkness is not a void that swallows things. It is a velvet blanket that protects them. It is the waiting mentioned at the start, the potential for everything that is yet to be. Astronomers didn't expect the universe to be so quiet at its limits. They expected to find an edge, a boundary, or perhaps a chaotic mess of energy. Instead, they found the cosmic microwave background, a soft, uniform glow that looks the same in every direction. It is the most infinite thing we have ever discovered, a reminder that the beginning and the end are woven from the same thread. When we look at that light, we are looking at the very first moment of the universe, but we are also looking at the background of our own lives. It is the ultimate, loop-safe environment. Nothing is lost, nothing is wasted, and everything eventually returns to the same calm equilibrium. Think of the rogue planets we discussed earlier. In this infinite ending, their journey makes perfect sense. They are the heralds of the quiet future. They move through the dark without the need for a sun, carrying their own internal warmth and their own silent history. They are proof that a world can be complete within itself, even in the absence of external light. You, too, are complete within yourself in this moment of darkness. You don't need the sun to define your existence. You have your own internal rhythm, your own heartbeat, and your own steady drifting thoughts. The silence of the infinite ending is a healing silence. It is the silence that allows the mind to repair itself, for the cells to regenerate, and for the subconscious to sort through the day's experiences. It is a productive, vital stillness. In the deep reaches of space, this same stillness allows the gas to cool enough to eventually collapse into new stars. Without the dark, there could be no light. Without the ending, there could be no beginning. The two are not opposites. They are the same process seen from different angles. As the words of this script begin to thin out, imagine the universe as a vast, dark ocean. You are floating on the surface, supported by the density of the water. Beneath you are the depths of the great void. Above you is the light of the cosmic web. You are perfectly balanced between the two. The current is moving you gently, not toward a waterfall or a shore, but in a slow, circular motion that brings you back to where you started, but with a deeper sense of peace. The infinite is not a distance you have to travel. It is the quality of the moment you are currently in. Everything is exactly where it needs to be. The atoms of 55 Cancri E are vibrating at their own pace. The molecules of Sagittarius B2 are spinning in their rum-scented clouds. The stars of the Andromeda Galaxy are beginning their long trek toward the Milky Way. And you are here, in the quiet, moving at the speed you need to move. There is no faster, no slower, only the natural tempo of your own existence. The universe will still be here when you wake, but it will be slightly larger, slightly cooler, and slightly more mysterious than it was when you fell asleep. It is moving forward, quietly and endlessly, and you are an essential part of that movement. You are a witness who has seen the Diamond Mountains and the great voids, and now you are a witness to the beauty of the dark. The darkness is merely waiting for your dreams to populate it, for your mind to find its own strange and beautiful patterns in the shadows. Do not look for a conclusion. Do not wait for a goodbye. The universe does not say goodbye. It only says, continue. It is a conversation that has been going on for 14 billion years and will never truly end. We are just stepping away from the microphone for a while, allowing the background hum of the cosmos to take over. The radio waves of the alcohol clouds, the gravitational hum of the merging galaxies, and the soft microwave glow of the beginning are all playing a lullaby that is too low for the ears, but perfectly suited for the soul. This conversation doesn't require our participation to remain meaningful. It is a dialogue between gravity and light, between expansion and entropy, spoken in the language of shifting frequencies and cooling matter. As you drift closer to the edge of sleep, you are simply leaning back into the cushions of the cosmos, letting the vastness hold the weight you've carried all day. To understand why there is no goodbye, we must consider the nature of information in the universe. Scientists suggest that information, the blueprint of every atom, every star, and every memory, may never truly be deleted. Even if an object falls into a black hole, its story is preserved on the surface of the event horizon, etched into the geometry of space-time itself. This is the ultimate continuity. Nothing is ever truly lost. It is merely transformed or filed away in a different part of the cosmic library. You are part of that permanent record. Every breath you take and every dream you have is a new line in a book that has no final page. The universe doesn't need to say goodbye because it never lets go of anything it has created. Imagine the universe not as a ticking clock winding down to a stop, but as a grand, infinite symphony that is constantly modulating into new keys. In the beginning, the music was loud, dense, and hot, a single, overwhelming note of pure energy. Over billions of years, that note has harmonized and branched out. It has slowed down into the rhythmic orbits of planets and the steady low-frequency hum of pulsars. When we sleep, we are simply tuning our own internal rhythm to this slower movement. We are dropping the tempo of our hearts to match the cooling of the stars. We are becoming a quiet chord in a much larger arrangement. There is no need for a conductor to signal the end, because the music is the very fabric of existence itself. In our human-scale lives, we are often obsessed with closure. We want to finish the project, resolve the argument, or reach the destination. But the strangest thing we've discovered in space is that the universe is perfectly content to be open-ended. The Great Attractor continues to pull us toward an unknown point. The expansion continues to push the galaxies apart. The dark energy continues to accelerate the void. These are not problems waiting for a solution. They are the fundamental conditions of the journey. There is a deep, quiet humor in the way we try to apply our small deadlines to a system that measures time in eons. The universe isn't waiting for us to catch up, nor is it leaving us behind. It is simply moving, and we are moving with it. Consider the stelliferous era, the age of stars that we currently inhabit. It is a bright, beautiful chapter in the life of the cosmos, but it is just one chapter. Eventually, trillions of years from now, the last star will exhaust its fuel and fade into a black dwarf. To a human mind, this might seem like a conclusion, a dark ending to a bright story. But to the universe, it is just a change in density. It is a shift toward a more stable, quiet equilibrium. Even in that distant dark, the laws of gravity will still be in effect. The rogue planets will still be wandering, and the black holes will still be evaporating through the slow leak of Hawking radiation. The conversation will continue, whispered in the dark, long after the bright lights of the galaxies have been turned down. This perspective allows us to view our own rest as a form of cosmic participation. When you close your eyes and let the world of things fade away, you are mimicking the eventual state of the universe, a state of pure, undisturbed potential. You are returning to the baseline. The darkness of your room is a small, local version of the great cosmic voids. And just like those voids, it is not an empty place. It is a place where new thoughts can coalesce, where the mind can regenerate, and where the self can dissolve back into the silence. You don't need to fear the dark, because the dark is where the universe does its most patient work. The radio waves of the alcohol clouds are still out there, crossing the light years at 186,000 miles per second. They are passing through the walls of your house right now, invisible and silent, carrying the chemical signature of a raspberry-scented heart of the galaxy. The gravitational waves from a merger of two black holes, millions of light years away, are gently stretching and squeezing the space in your room by a fraction of an atom's width. These are the subtle lullabies of the infinite ending. They are reminders that you are never truly isolated. You are constantly being washed by the tides of a very large, very ancient ocean. And somewhere within all of this, in the gaps between the stars, in the silence of the voids, in the heat of the diamond worlds, we can begin again by starting with something familiar, the sensation of being still, the weight of the air, the rhythm of a single, peaceful breath. As we move into the final dissolution of these thoughts, let the scale of the universe be your blanket. Let the light years be your pillow. The distance is not a barrier, it is a cushion. The time is not a limit, It is a resource. You have all the time in the world and all the space in the universe to simply exist. And the strangest thing we have discovered is not an object, but a feeling. The feeling of being completely and utterly at home in the infinite. The universe does not say goodbye. It only says continue. And so we continue, slowly, quietly, endlessly. Dot, end, dot. Into the dark, into the peace, into the rest. Good night.